Hi there. Okay, today we're going to be doing ionic bonding. Okay, so this is the other major concept for this booklet, and one of the other key things that we want to understand when it comes to chemistry in grade 10. So a little background on ionic bonding. We're starting on page 6 here. Okay, so with ionic bonds, the bond is formed by the attraction of opposite charges. Okay, so here opposites attract. You would have a positive ion and a negative ion, and then together they make that bond, which you would have seen in the brain pop video. Okay, so for an atom to become chemically stable, because remember, that's what all atoms want to be. They just want to be stable, like their closest noble gas. So its outermost shell has to be full. Okay, so it wants the outer shell to be full. The inner shells are already full. The outside one has to be full. So with the exception of hydrogen and helium, whose outer shells only hold 2 electrons, the atoms in periods 2 and 3, those elements require 8 electrons in order to fill their outer shells, and we call this the stable octet rule. Okay, octet means 8, right? They need 8 electrons in their valence shell in order to become stable. That's where that comes from. Okay, after the third period, the outermost shell holds way more electrons, and that's another reason why we really don't go past element number 20 or the third period. Okay, here we go. For ionic bonds, atoms will either gain or lose their valence electrons to achieve stability. If an atom loses or gains an electron, because remember, that's the only thing that can move, right? Protons and neutrons, they can't move, just electrons. So if an atom loses or gains an electron, it becomes an ion. Okay, and this is how I remember what becomes what. Okay, so here, notice how the word cation has a big T, and there's also a T in positive. Okay, so this is how I remember that cations are positive. Okay, and on the flip side, anions, they have a big N and big N for negative. Okay, and this is how I remember that anions are negative. Okay, so anions, I also remember them like onions. Onions can make you cry, they make you sad. That's a negative experience. Onions, anions, just a different letter in front. That's another way that I try to remember it. Okay, so we're going to have positive ions and negative ions, either cations or anions. Turn the page. Okay, take out your periodic table here. Families 1, 2, and 3. Okay, so we're going to look at family 1, 2, and 3. I know this says 13 in front, but for our purpose, you can just cover the little 1 in the front, cover the little 1 in for the 14, 1 for the 15, and 1 for the 16, when we're just looking at these first 3 periods. Okay, so for families 1, 2, and 3, this is the alkaline metals, alkaline earth metals, and group 3. Oh, lies, sorry. No, I was right. The first way I was right. Okay, so they have 1, 2, and 3 valence electrons respectively. So elements in these groups tend to lose valence electrons. Okay, So they form positive ions, also called cations. Okay, and so the first family loses 1 electron, so that means it has a charge of +1. Second family loses 2 electrons, it has a charge of +2. Third one loses 3, it has a +3 charge. Okay, you see the pattern that's coming on here? So families 15, 16, and 17, so that's group 15, 16, and 17, the chalcogens and halogens, they have 5, 6, and 7 valence electrons respectively. And the easy way to tell the number of valence electrons is to cover the 1 or count from the beginning of the period, which I've already shown you. Okay, so elements in these groups tend to gain valence electrons. Okay, it would be a lot more work for them to try and lose 7 than to gain 1. Okay, so and they form negative ions. Oops, sorry. They form negative ions or cations. And if you called it cations, don't worry, it's not a big deal. Tomato, tomato. Okay, so here, group 15 needs 3. So when it gains 3, it has a charge of -3. Okay, all the chalcogens are short 2. Okay, they are missing 2 electrons. Once they've gained those 2 electrons, they have a charge of -2. And same thing here, chlorine is short 1. When it gets that 1, it has a charge of -1. Okay, so note, protons cannot leave the nucleus of the atom. Only electrons can leave. Okay, therefore the charges of ions are solely determined by the electrons lost or gained. Okay, the protons determine what atom it is, okay, and electrons determine the charge. Okay, turn the page. Okay, stable octet rule. We'll talk about this just a little bit more, especially because we're not doing this in class together. Okay, so number 1. One atom will react with another by gaining electrons, losing electrons, or sharing electrons. Okay, so remember that the gaining or losing, this forms ionic bonds. Okay, and losing, this is ionic bonds. And sharing electrons, this is covalent bonds. But covalent bonds still want to form that octet rule. They still want to become stable. Okay, but they're the only ones that share. The number of electrons gained, lost, or shared is such that the atom will end up with a full outer orbit. Okay, and more precisely, the atom will end up with the same number of electrons as the noble gas that it is nearest to. Nearest to in the periodic table. Okay. Number 3, the number of electrons gained, lost, or shared is referred to as the combining capacity. Combining capacity. So the charge, also known as the combining capacity of the element, and is the same as the ion charge. Okay, so here's a couple examples. Okay, so sodium Na. Okay, if we look on our periodic table, sodium is right here. Okay, so it's in the alkali metals family. It has only 1 valence electron. Okay, so it's going to lose 1 electron to become Na plus 1. Okay, so its combining capacity is plus 1. Okay, so note that this is the ion charge. Also, notice that it's a superscript. That it's a superscript. Okay. It is written above the symbol, not beside it. Okay, because writing a number right beside it works more like a coefficient. Okay, and remember, writing it below tells us how many of that one atom we have, right? So take a look at oxygen on the periodic table. How far away is it from becoming stable? So here's oxygen, 1, 2. So it is short 2 electrons before it can become stable. Okay, so it wants to gain 2 electrons to become O -2. Okay, so its combining capacity is -2. That's it. That's how that works. Okay, turn the page. Okay, how are 2 elements combined? So 2, also called binary compounds. Okay, so we're always dealing with 2 elements. That's what the bi and binary means. Okay, so for ionic bonds, we always need to have a metal and a non-metal all the time. Okay, so if we had 2 nonmetals, it would be a covalent bond. If we have a metal and a nonmetal, it's ionic. Okay, and it is a transfer of electrons. Okay, it's either giving and taking, not sharing. So the metal is always going to lose the electron and it becomes a cation. Okay, it has a positive charge. Nonmetals always gain electrons and they become anions. Okay, they have a negative charge. And the attraction between negative and positive ions gives us our ionic bond. Okay, compounds that are formed this way are called ionic compounds. That's it. It's really not that bad. Now, here is the meat and potatoes of it all. Okay, turn the page. Can you highlight this? Put a big star. This is the page you're going to come back to all the time. Stars, stars. Okay, this is the page. This is key. Okay, this is the steps for pretty much doing ionic bonding. Okay, so the first thing we want to do is we want to write down our ionic symbols. So I'm going to start with this one in the middle here. Okay, so I have lithium and oxygen, so I have the symbols Li and O. Okay, the next thing I want to do is write down the combining capacity. Okay, so let's take a look. Li is over here. Okay, Li's combining capacity is going to be 1, right? It's in the first column, so it has 1 valence electron. So I'm going to have +1. Okay, because we know that it's going to want to get rid of because it has 1 extra. And oxygen over here, 1, 2. So we are 2 away. It's the non-metal, so it's going to want to, it is short 2 electrons. Okay, so that's step 2. Okay, step 3, we're going to drop the positive and the negative. Okay, so I can cancel out the plus and the minus. Okay, step 4, crisscross the combining capacity. Okay, so I'm going to take the 1 from lithium and bring it down as a subscript to the oxygen. Okay, so from a superscript down to a subscript. Okay, and same thing for oxygen, from a superscript down to a subscript for lithium. Okay, so now we go from lithium having a charge of +1 and oxygen having a charge of -2. Now it's telling us that for every 2 lithiums, we need 1 oxygen in order to be stable. Then we look, can we reduce if necessary? Can I divide either of these further? No, oxygen is 1. We can't divide both of them by anything, the same number, so we leave it. And then you drop any 1s, okay? So you don't need to write the 1. And then you push it together, okay? So you're gonna have Li2 and with your O right next to it. Okay, and that is how you write the formula for an ionic bond. Okay, let's try this one here. Okay, so Na, find Na on the periodic table. Okay, and I'll tell you too, for the metal is always written first, the non-metal is always written second. Always the metal first, always the non-metal second. Always the metal first, always the non-metal second. Or better to think of it, cation, ion, cation, ion, cation, ion. Okay, so Na, what's the charge for Na? Right on, okay, +1. What is the charge for chlorine? Here's chlorine, okay, -1. Okay, so we did step 1 and step 2. Step 3, drop the positive and negative, okay? So we always want to make sure we have our positive one first and our negative second. Now we're going to crisscross. So I'm going to bring this one down here. And then I'm going to bring this one down here. Okay, so now I just have 1s. Okay, and now we can we can reduce if necessary. We don't need to, and then drop any 1s. So we actually don't have to write the 1s. So what do we have left? NaCl. Okay, that means that for every 1 atom of sodium, we need 1 atom of chlorine for them both to become stable. Okay, let's try over here with aluminum. Okay, so what's the charge for aluminum? Find it on your periodic table. Right on, the charge is +3. Okay, what's the charge for fluorine? -1. Okay, so drop the positive and the negative. Okay, crisscross, bring the 3 down, bring the 1 down. So now I'm going to have F subscript 3, A subscript 1. Okay, can I reduce these any further? No, I can't divide both by 2, I can't divide both by 3, so I can leave that, and then I'm going to drop any 1s, and when I write it again, I'm going to have Al F3. Done. Okay, so that's how we put the names together. Okay, that's how we write the formulas. Now, how do we name them? Okay, naming is really easy. Okay, so the cation or the metal always goes first. Okay, and the anion or the non-metal always goes second. Okay, and then just like covalent bonds, we change the second element's ending to IDE. Okay, so it shows here if we're adding chlorine and sodium together, okay, sodium is the metal, chlorine is the non-metal, okay, so it would be sodium chlorine, but we change the ending from INE to IDE, sodium chloride. Okay, let's give this a try. Turn the page. Okay, activity number 4 says write the formulas and the names for the following. Okay. I'm just going to do a couple with you and then I will post the answer. So I will do A and B with each of you and then I will post the rest for you to check. Okay. So write the formulas and the names for the following. The first one says Li plus 1 and Cl minus 1. So down below here, I'm going to write that out. 1A Li plus 1 and Cl minus 1. Okay, so what is Li? Right on. So we have lithium, and Cl stands for chlorine, and we combine those together, we get lithium chloride. Remember, don't forget to change the ending, right? Lithium's the metal, chlorine is the non-metal, okay? 1B, we have Al plus 3 and I minus 1, okay? So Al stands for aluminum, I stands for iodine. When we combine them together, we get iodide. Okay, so we drop the last few letters and we change the ending to IDE. Right on. Okay. 1C. Oh, you know what? This one actually has something interesting I want to show you. Okay. So 1C, we have Ca plus 2 and O minus 2. Ah, never mind. It actually didn't show you what I want to. Okay. Yes, it does. Okay. So when we want to write this out, we have calcium and oxygen. And when we move them together, we get calcium oxide. Okay, so there's the name, but it also asks you to write the formulas for them as well. Okay, so let's do that as well. For Li plus 1 and Cl plus 1, now let's do that here. Li, Cl, okay. When I crisscross and combine, I'm going to get Li1, Cl1, and we drop the 1s, so we just get LiCl. Okay. Over here we have Al plus 3 and I minus 1. Okay. When we crisscross and combine, we're going to get Al subscript 1 and then I subscript 3. Drop the 1, push it together, and we get Al I 3. Okay, I'm trying to keep it color coded so that you can see where those charges are coming from and where the numbers go. Okay, and the next one here, calcium, we have Ca plus 2 and O minus 2. When we crisscross and combine, we're going to get Ca2 and O2. Now, here we can divide both of these by 2. So 2 divided by 2 gives us 1. 2 divided by 2 gives us 1. So that's the same thing as saying Ca1, O1. And because you can drop the 1s, you're just left with Ca and O. Okay, right on. For D, what do you get for D? The answer is BaF2, and the name is barium fluoride. Okay, take a look at number 2. Number 2A says write the formulas and the names for the following. Okay, the first one says sodium bromine. So we have sodium and bromine. Okay, so what's the symbol for sodium? What's the charge for sodium? Okay, what's the symbol for bromine? What's the charge for bromine? Okay, so when we're doing this, make sure you pause the video, find it on your periodic table, and then keep on going. Okay, so when we crisscross and combine, we're going to get Na1 and then Br1, and then we drop the ones, and so we just have Na, Br. And what is it called? Sodium bromide. Okay, don't forget that. 2B, we have barium and chlorine. Okay, what's the symbol for barium? Okay, that's Ba. What's the symbol for, oh, what's the charge for barium? +2. Chlorine is Cl. Okay, and what's the charge? Chlorine, what's the charge for chlorine? Okay, -1. Okay, when we crisscross and combine, we're going to have Ba1, and then we're going to have Cl, and we bring that 2 down, Cl2. Okay, when we drop the 1 and push it together, we get Ba, Cl2. Okay, excellent. And when we try and name it, barium chloride. Okay, right on. Get ready to pause the video so you can try the next one before you check your answer. Okay. Okay. 2C, potassium and oxygen. Okay, charges for potassium, oxygen. When we combine them, and finally, and that's it. Okay, and what's the name? Okay, right on. 2D. It says aluminum and sulfur. Make sure you're actually trying this yourself. It does no good if you're just listening. You should pause and try it yourself, which I'm sure you probably are, but just in case. Okay, aluminum and sulfur, periodic table. Aluminum, oh, it's over here. What's the charge? So I start here, 1, 2, 3. Okay, 1, 2, 3. Okay, so we're gonna have Al +3 and sulfur right there. So sulfur is 1, 2. Okay. Okay, so when we crisscross and combine, we have Al2, and then we have S3. Push them together, and we get Al2, S3. And what's the name of it? Aluminum sulfide, right? Don't forget that ending. Okay. 2E, we have silver and chlorine. Okay, now silver is a bit special. Okay, silver on the periodic table here is there, Ag. Okay, number 47. So the symbol is Ag, but how do we know what the charge is? Okay, silver here is a transition metal, which means that the charges can vary greatly. So what you want to do is grab that other periodic table that I gave you. okay? Professor Moker's periodic table, and here you're gonna see it gives you all the charges for all the ions, okay? So here is silver, where's silver right here, and that tells you the charge right there. So the charge for silver is +1, okay? You can't use that little trick that we were using to find the charge for silver because it is past the 3rd period, which means there's just a whole lot more stuff going on. Okay, so to simplify it, you can just use that Professor Moker's periodic table of charges. Okay, and then we have chlorine here, and chlorine is -1. So when we crisscross and combine together, we just get AgCl. And what's the name? Silver chloride. Okay, and then for the last one, it says write the formulas for the following compounds. So A is potassium chloride. Stop, try it, and see if you get the same answer. KCl. Okay, B C and D. Right on. Awesome. Great job.